material that I am discussing in here. So next is going to be about electronic throttle control system, or from now I'm gonna just call it ETC, electronic throttle control system. Well, what we are going to talk about is about the circuit, the components, and also troubleshooting. Like all other lectures that I was just introducing, what is included in the system or in the circuit, which components, how is the functionality of the components, and which kind of issues might be there. In case they are faulty, how to troubleshoot them. So these are the things that I am going to include in today's lecture. So I have already finished this part, which is the cranking system, right? And right now I am talking about electronic throttle control system, and I will record this one and I will post it for you by the end of the day. So the remaining is not going to be included this semester. Well, now, as I said, what we are going to talk first is the fundamental, then I'm gonna look at the components included, and later I'm gonna just discuss the troubleshooting and any issues that is a reason of having like a faulty ETC. Let's start with the electronic control unit, or ECU, which is a well-known, let's say, term to all of you since I introduced the ECU in the first few lectures in the beginning of the semester. So I told you that we do have a computer in every vehicle, that this computer is going to check or monitor the functionality, or let's say the operation of many sensors and actuators included in the vehicle. So they are calling this computer with different names. Sometimes they call it like ECU, some they call it ECM, or let's say electronic control module. Some they call it electronic control assembly, or ECA. So any of these are correct. But the CAE standard is calling it powertrain control module, or PCM. So today we are going to look at this. We are going to use PCM in this lecture, which is going to be the powertrain control module. Now, what is powertrain control module? Actually, this is acting like the brain for the vehicle. So it is going to receive some information from the sensors and actuator, and it will manage the engine, the transmission, and any of other systems based on that information which is received from the sensors and actuators. So let's say almost 40% of its capacity is busy with checking or monitoring the sensors and actuator, and the remaining is doing the other normal job of a computer. So the PCM is going to check the functionality of the sensors and manage or monitor the engine's ignition system, fuel injection, emission systems, let's say mechanical positioning of the rotating assembly, exhaust system, transmission, and any other functions which is just based on the operation of the engine, or let's say kind of connected or related to the operation of the engine and transmission. So all of them are going to be done by PCM. Now, let's see what is throttle control system, which is also connected to PCM, and it is going to be controlled by PCM. Throttle control system controls the air-fuel mixture that your engine burns, right? So it is also checking the flow of air. So it simply regulates the flow of air to the engine when you push or press the accelerator pedal, or let's say the gas pedal. So which is very important part in your car, especially if you are driving a combustion engine. As I mentioned, I am going to call it ETC. ETC has different mechanism, as you can see in here. It is going to have mechanical, cable, and electronic. What does it mean? It means it is going to, so this is the pedal, the gas pedal. For every type of car, it is going to be the gas pedal. But the connection between this and the body, either it can be done using a mechanical linkage or using a cable. This is a cable, or using some electronic part. That's why we say there is different mechanism for the operation of the ETC. Well, in this lecture, I am going to look at the one which is going to be like more common in recent car, in more modern car, in today's car, which is going to be the electronic connection between the pedal and between the throttle body. So that's the one that we are going to use for today's lecture. So there are some advantages of a drive-by-wire, which is going to be this one, throttle. For example, if we have less mechanical components, look at here, we do have some mechanical components in here. This is cable, it is not mechanical component, but still, we are not going to use this one. There are some disadvantages for this one as well. So now, if we compare this one with this one, if we have less mechanical component, then we have faster dynamic, and it will reduce also the weight of like the total car as well. So any extra mechanical component, of course, it is going to add some weight to the car. And we know that if the car is like lighter, of course, it is going to be faster. So because there are few parts in this type, which is going to be the drive-by-wire, this is the preferred method. And it is going to help to take some pressure off of the engine because there is less mechanical parts involved in this one. So also if we use the drive-by-wire technology, the manufacturer are going to have more opportunity to position the control system within the cabin of the car. So because it is not going to be something huge and something big and something heavy anymore, so they can just position it. This is wire, they can pass it from like everywhere easily, much easier than this one within the cabin. So this is going to be another advantage of the drive-by-wire. Also, the engine doesn't have to work as hard as I mentioned, since it is going to not to have more mechanical, and the drive-by-wire technology weight is less, and we need less fuel as well. So this is another benefit. We are going to have less fuel. So it means we are going to save some money on gas as well if you are using the drive-by-wire. Well, the other advantages is also the drive-by-wire throttle technology work in combination with several electronic safety features that we are not going to get those benefits if we are using the mechanical type. So for example, blind spot detection, adaptive cruise control, electronic stability control, and lane assistance, all of these are just working using this type of connection, which is going to be the drive-by-wire. If you are using this type of connection, you won't get the benefit of using any of the features that I just named them in here. Well, here you can see more components involved in ETC circuits. I'm gonna just explain them, and then I have a short video for you, like less than maybe 2 minutes, even 1.5 minutes or so, that will kind of summarize whatever I am going to explain. So if you look at the picture, you can see the first thing that you need in here is going to be this accelerator pedal position or APP sensor, which is going to be this sensor, which is attached to here. This is one component included in the circuit, which is a very important component. So this one is going to measure the pedal input from the driver using this sensor. What does it mean? It means whatever pressure you are applying to the pedal gas is going to be detected with this one, and it's going to be sent to the TAC, which is a control module in here. And then that will define the status of the pedal or the status of the acceleration, let's say. You have another sensor in here, which is the throttle position sensor. This position sensor in here, or TP, it is shown in here as throttle TP sensor or position sensor. This guy in here is the one which is APP, or accelerator pedal with position. This is a feedback sensor. So this sensor in here is going to position the throttle to the blade. This is the blade of the throttle. So this is going to position the blade. This blade is also controlled by TAC module. TAC module is the throttle actuator control module. Since we do have a DC motor in here, for every DC motor, of course, we need an electronic module to run it, right? Otherwise, we cannot run this one. So this electronic module has many components such as edge bridge, such as also other components in order to run the motor. So what it is going to do in here, this one is going to run the DC motor. And also we need electronic module, as I mentioned, such as edge bridge included in here, and MOSFET to run this motor, right? So this is a DC motor, this is a throttle blade, and this is the sensor which is going to adjust this one based on whatever information which is receiving from the control module in here. So these are the components involved in this one. Now, when you press the pedal, let's say this is the pedal position in this graph. Which is going to be versus time. When you press the pedal position versus time is going to be something like this one. So the throttle actuator position is not, which is this one, this is the throttle actuator position. It is not going to follow the accelerator pedal position. The accelerator pedal position has a sharp jump, but your car, as soon as you press the pedal, is not going to jump, right? If it is mechanically, it might, but if it is electrically, it's not going to jump sharply. So because this throttle actuator position is not following that one. So because the engine has a dynamic and you cannot apply too much of air to the engine, so the throttle plate will open with something around, let's say, 30-second delay. And that's the reason that the throttle actuator position is not jumping like that. It will activate it. It will be active with like some delay. So when you press the pedal, the car acceleration is not jumping to have like the efficiency in combustion process. The dynamic will be defined in the TAC, right? So when it is receiving a sharp command from the pedal, and it will be then immediately adjusted within like 30 milliseconds, and then the throttle position sensor will send the feedback to here, to TAC module, and then the throttle blade, which is going to be this one, it will be opened based on the feedback which is receiving from here. So it will be controlled. This blade is controlled with the TAC, and it will adjust the acceleration based on whatever it is receiving from here. But with mechanical linkage, this process will happen sharply, and then you have less efficiency in the combustion engine. Now, let's watch this short video to clarify a little bit more about the performance of the throttle actuator control system. I think I didn't share sound. Let me first share sound. Why this is not playing? Let's play it.
The throttle actuator control replaces the need for mechanical linkage between the throttle body and the accelerator pedal. It also replaces the need for an external cruise control module and an idle air control valve. G'day, I'm Zach. Welcome to Automate. TAC systems enable the integration of adaptive cruise control, electronic stability control, traction control, and active braking control with the engine management system. Removing the amount of moving parts also saves money and reduces servicing costs. A TAC system consists of an accelerator pedal, position sensors, an engine control module, and a throttle body assembly. The driver's torque request is communicated to the ECM via an accelerator pedal voltage signal. With this information processed, the ECM can command the throttle valve motor open or close, achieving the desired torque. The ECM can make adjustments to the throttle valve without the input from the accelerator pedal. Fast idle can be seen during cold start conditions or when the air conditioner has been turned on. The ECM may command the valve closed during a traction or active braking control moment, regardless of the driver's torque request. A TAC system on a common rail diesel has no control over the throttle valve assembly. The valve is normally in a wide open position. Again, the job of the accelerator pedal position sensor, or APP, is to convey the driver's torque request to the ECM. There are different types of APP in use in current motor vehicles: a variable resistor with 2 position sensors for redundancy, or a contactless position sensor. To continue watching this video, you need an Automate.
So now I am going to introduce the different type of it, but before that, are you seeing my slides?
Yes, we can see
Okay,
him.
good. So here you can see the components with more detail. As I mentioned, the APP sensor, or you saw in the video as well, it is going to just monitor the accelerator pedal position. So it means it is the accelerator pedal position sensor, which is made from 2 or 3 sensors. In the video, you saw it with 2 sensors, but there are vehicles that they do have 3 sensors as well. So it is going to be either 2 or 3. So, and it is simply a combination of, let's say, 2 or 3 potentiometer, right? So it is just the performance of a potentiometer, or let's say a variable resistance. So the accelerator pedal sensor transmits the position of the accelerator pedal to the engine control unit. That's what it is doing. So when you press the pedal, a voltage will be generated, and then the tag, which I just showed in here, this module, what it is doing, it is going to receive the Bose data from the sensors. You do have either 2 or 3 sensors, right? So let's say we do have 2 sensors. One is decreasing, as you can see in here. One sensor decrease with pedal position, and the other sensor is going to increase. So the tag is receiving the data from both sensors at the same time, and it will check the status accordingly. So this is how this APP sensor is working. Now, the other part of the throttle is going to be the throttle body, which is going to be this thing, right? This is the blade. You just saw it in the video, how this is going to open and close. And this is a function of the command which is receiving from the gas pedal. And based on that, it will open and close. So what you are seeing in here, this is the electric motor, right? And you have some gear in here as well. So you have gear in here. This is the motor, and this is the blade. This is the construction of the body, the throttle body. So how this is working? The body assembly regulates the amount of air that flows into the engine, as I mentioned, based on the command from the throttle or the gas pedal position. So it has a blade which is holding this part, which is going to be the motor and the gear. And then it has a clock, a spring, you don't see it, it is back there. And until you press the gas pedal, it is going to be in natural position. But after you are pressing the gas pedal, the position is going to change. So since there is no acceleration initially, or let's say we are going to be in safe position, we call it safe position or natural position, right? So which is about, let's say 60% to 20% open. When we are in natural position, this is, let's say 60 to 20% open. But the remaining is going to be adjusted based on the commands from the throttle or gas pedal position. So there is also an electric motor, as I mentioned in here, with a gear in back there to control the blade, or let's say close and open the blade. That's what this motor is going to do. So these are the parts in the throttle body. Well, there is another sensor, which is the position sensor or TB, which I have already introduced in the circuit of the throttle. So we do have this TP. This is going to function very similar to the APP because it is going to be also a combination of two potentiometers. So the sensor's job is to define the position of the throttle and communicate it to the engine control module. Or let's say, so as I mentioned, sometimes they say engine control module or ECM, sometimes they say ECU, or in here we say PCM. All of them are the same. So it can receive the position of the throttle and it will communicate it with either ECU, ECM, or PCM. So this is going to be very similar to pedal position sensor. And but the difference is these two potentiometer in here, they are going to work in reverse direction. So one start from 0.5 to 4.5 volt. The other one will start in a reverse direction. It will start from 4.5 to like 0.5. That's the way that these guys are going to work. So the potentiometers in here, which you can see it in here, it will provide a variable resistance based on the position of the throttle valve, and the sensor signal is going to be an input or command for the engine control module, and then the engine control module will act based on that, which is going to be this one, TAC module, right? This is how the system is working. Recently, many of the TP sensors are magnetic based, as you saw just at the end of the video. This is exactly what it was in there, but with no explanation. I'm going to explain it for you. So it is a magnet with different poles and a Hall effect sensor that is used in a sort of variable resistor. So when the magnetic field is passing through the Hall effect sensor, it will generate a pulse like this one in here, which is going to be an on and off, or let's say positive and negative pulse. So, and the pulse is based on the rotation of the magnet of like this magnet, which can be defined as the status of the throttle. Again, this is going to be based on whatever you are receiving from the driver, right? Or let's say from the gas pedal. So next is going to be about the throttle body motor control. Remember I said there is also other components in here, which is like the entire mechanism in here is going to be a servo mechanism to control the position of the throttle. So there is a DC motor, right? And when you apply the voltage, it will have a control, let's say continuous 60-degree rotation. So we need to have a PID controller to adjust the angle of the rotation of the motor. This angle can be adjusted between, let's say, minus 20 degree to positive 20 degree. How to do it? We have to do it using a feedback control system or PID control system. Let me just write simply in here. Let's say you have a DC motor in here. So you have the sensor attached in here. So this is the sensor, right? And then what do you have in here? You have a feedback system. This feedback is coming to here. Here is your input. Let's say if this is going to be positive. So this is going to be your feedback system. What you need? You need a controller in here, which is going to be a PID controller. And this PID controller can just adjust the angle for you. So we need for adjusting the angle. I discussed this in the previous lecture. You need to have an H bridge, and also you need MOSFET. Remember, we practiced it, group A practiced this in the last lab. How we can just change the direction of rotation of the motor. So that's what we do using an H bridge and a MOSFET. Group B, you will be practicing this in lab 5 tomorrow, and you will see how we change the direction of the rotation. This is exactly what I am explaining in here. So now, there is a test which we call it ETC test. So this is ETC, a spring test. If this test is not passed, the power control module, or let's say the PCM, is not letting the cranking of the system, or let's say it's not gonna crank the engine. So always this is going to control the engine. If this is going to successfully pass the test, then the engine will start. Otherwise, it's not gonna start. So the PCM is sending a command to the throttle to fully open and close. It must be fully open and close. So this will happen 3 times. The test is gonna repeat 3 times to check the throttle position sensor is showing the maximum and minimum. Then the PCM after that will let the engine to crank. Otherwise, engine will not going to crank. This is how this test is going to help. And the next slide in here, if you have a faulty ETC, the PCM will turn on, and then the check engine light will also turn on your dash. That's what you are going to see. So the PCM is allowing the engine to only work in the range of 1200 to 1600 RPM. Anything after out of this range is not going to work. So if you have this RPM, but your engine is not cranking or is not started, then you have a faulty ETC and you need to check it. Sometimes the check engine is on at the same time that your cruise controller is going to be disabled. So check engine is on at the same time, cruise controller is disabled. That's another reason to say, okay, I do have a faulty ETC. Or if you press the pedal, your car is not accelerating. Or if it is also accelerating, it is going to be very slow. So a slow acceleration or no acceleration is going to be another reason to understand, okay, you do have a ETC faulty, which is going to be checked and also fixed. So how to do it? There are some special tool, or let's say kind of a scanner, that you can simply scan the sensors and see if the sensors are faulty, they are broken or damaged. You can find out the issue and you can replace it. And this is going to be about when you replace the sensors. You find out the faulty sensor, you replace it or you fix it. After that, it is very important to again calibrate your new APP sensor. Otherwise, it's not going to work properly. So you need to calibrate. It is important to calibrate your sensor. And when you wanted to calibrate it, you need to go over this procedure. If not, if you don't calibrate it, then you will experience some shaking or noise issue of the car, and you don't want that. So the calibration process is going to be like this. First of all, you need to make sure the pedal is not pressed. It is fully released. Sometimes even you may need to make sure, checking it with hand. Sometimes your your foot is not in there. So you may think, okay, this is now fully released. But sometimes there are other resistance in there. It is better to check it with your hand, make sure it is in a natural position and it is completely released. That's the first thing that you need to consider. Then you need to push the start button if your car is just starting with a push button, or use the key to start the engine and wait for almost 2 seconds, right? The next step is you need to turn off the car and wait for another 10 seconds. And then just repeat the same process for the second time. This is how you can calibrate your APP sensor in case this is a new one or you replaced it, right? So, but what if you have some bouncing or shaking during idle? So then again, you need to look at the situation like, okay, you might have some dirty throttle body, like the one that you had some dirty cranking part. So in here, this part, which is going to be the body, might be dirty and you need to clean it up, right? So what you need to do, you need to again turn off the engine, remove the air inlet. This is the process for cleaning. And then clean the throttle body. There are some spray out there in the market which are just for this purpose. Use one of those, clean up the body properly, and then put it back. Also, it is very, very important that you always need to consider again safety procedure, since the throttle blade is very sharp, right? This part is very sharp. You are not going to just do it without making sure that the engine is off, the battery is disconnected. So I see here and there in the reports that many people are losing their finger or hurting, damaging their finger because they just put their finger when they are just cleaning up this one in here, and then either accidentally somebody else in the car is turning on the engine, or there are some power which is saved on the battery. Also, the car is off, which will make this running and it will hurt them. So you need to make sure that there is no connection with the battery. You make sure that the car is off and then go through that cleaning process. And finally, as the last slide in here, I'm going to just talk about, again, replacing or cleaning. So after replacing or cleaning, also, you need another kind of, let's say, relearn procedure, or we call it, again, calibration. Both of them are the same thing. So for kind of relearning procedure, you need to consider some steps as well. So again, you make sure the pedal is released, make sure check it even manually, and you have enough charge in your battery, something about 8 volt. Also, most of the component sensors, they are working with 5 volt, but since we always have some resistance, you have to make sure you have something over 5 volt, let's say even a little bit even higher than 8 volts, to make sure that you have enough power for operation of all of the sensors. And also, you need to make sure that you are running such a calibration or relearning in a certain temperature of the engine and certain temperature for the either room temperature or, let's say, environment temperature. So because there is a certain range for the engine needs to be in the range of 5 degree to 100 degree, the temperature of the engine, when you are going to just go over this procedure. And also, you are not going to do this maybe during the winter outside when it is very cold, because also the temperature outside needs to be at least 5 degrees as well. So this is another thing that you need to consider. And then when you are done with this procedure, you need to start the car for 30 seconds and then turn it off for another 30 seconds to complete the relearn procedure. So at this point, I am done with this lecture. I'm gonna stop right in here. As I mentioned, the first thing I want you to do right now, go over this part, which is going to be the cranking, charging and cranking system. So I encourage everybody right now, click on this link, complete this quiz, and I'm gonna record this part offline for you, and I will post it by the end of the day. After you are done with this quiz, come watch this recording, and then the recording for VAP. I'll post it with this name. Watch the recording. This one is already done. I will just post this recording of the lecture that I just offer as well. Watch both of them and then complete this quiz. And this is the way that you can make sure you will be good for the final exam. So I'm gonna stop at this point, and I'll be in the session. Let me know if anything.